So, hello friends. In this lecture, I'm going to explain a very important part of Fourier transform. Important part in why I'm saying because this lecture will contain first how we solve integral equation using Fourier transform. Then I will try to explain two most important part topic of Fourier transform. One is called Convolution Theorem and second is called Parseval identity. So let me start uh, integral equation. Solution of integral equation. So my friends, integral equation means the equation which contains integral also. So here I'm using Fourier transform. We are not going to solve every type integral equation, some special type. Suppose the question is solve the problem 0 to infinite f theta cos alpha theta d theta is equal to 1 minus alpha greater than equal to 0 less than equal to 1 and 0 if alpha greater than 1. Suppose this integral equation given. Now the question is how we solve using Fourier transform. Solve means we have to calculate fx or f theta value, correct? Because solution of any equation means calculate the values of y. So how we calculate f theta? So friends, see just what is given 0 to infinite f theta cos alpha theta d theta. If you know Fourier transform, then this is just similar to Fourier cosine transform, because what is Fourier cosine transform? FCS is nothing 0 to infinite fs fx cos sx dx. So it very similar, both are very similar, na? Correct? In place of x what is given theta, and in place of alpha what is given x. So right hand side is nothing a Fourier cosine transform of f theta. What is the value? 1 minus alpha greater than equal to 0 less than equal to 1 and 0 when alpha is greater than 1. In place of alpha, if you think it is s, and in place of theta if you think it is x, then what is that? 0, what is given? 0 to infinite fx cos sx dx is 1 minus s value greater than equal to 0 less than equal to 1 and 1 when s greater than 1. Means Fourier cosine transform of fx is given this one. So this is nothing. This is what is given FCS. Now our work is to calculate fx value. How we calculate? When fs is given, how we calculate fx? Using inverse Fourier transform. So using a inverse Fourier transform. What is fx? Fx is nothing 2 upon pi 0 to infinite FCS cos sx ds, correct? So just put the values. So what is fx? 2 upon pi 0 to infinite. What is fcx? It is defined only for 0 to 1. So limit we have to make change because it is valid only for 0 to 1. What is the value? 1 minus s cos sx ds. For remaining all value, the value is 0. So just calculate this integral and you would get the answer. So 2 upon pi 1 into cos sx or first into second. What is the formula? Liet. Use integration by parts. Already I explained. This is your first and this is your second. So first same to same. Integration of cos sx with respect to s is sin sx upon x. Correct? Because we are integrating with respect to s. Minus differentiation of this with respect to s, minus 1 will come, so it is plus integration sin sx by x ds and whole limit 0 to 1. So 2 upon pi 1 minus s sin sx by x, its integration with respect to s means cos sx upon x, so x square and minus sign will come. So what is the limit? 0 to 1. So friends, just put one time one value and second time put 0. And already I told to make correct answer, just do separately. What is separately? What is I1? I1 is nothing, just put x value, s value 1. Because we integrated with respect to s, so just put s value 1. So when you put 1, so 1 minus 1 is 0. This term is going to 0. Minus 1, s value 1 is minus cos x. Correct? This is going to be 0. When we put s value 0, what is I2? I2 is nothing. S value 0 means this value sin 0 again 0 minus 1 by x square. And cos 0 becomes 1. So this is your I1, this is your I2. So what is the integral value? I1 minus I2. So when we take minus, so it is plus. So 1 by x square minus cos x. This is your fx answer. So hope you understand. Any doubt? I don't think so because it's very easy. What is given, based on that, easily we come to know, yes, we have to calculate fx value using what? Fourier inverse transform. So just FCS value given, we put it. What they can do? Sometimes they can give here cos, in place of cos they can put sine, or using Fourier transform they can ask this type question. So hope you understand. Now I'm going to tell about convolution theorem. In every transform technique, we have convolution theorem. And convolution theorem basically used for to calculate inverse transform. So convolution theorem. What is that? Suppose fx is a function whose Fourier transform you calculated and it is denoted by fs. Now you calculated Fourier transform of some other function that is called gx, and we denoted it by gs. So Fourier transform of fx is capital Fx and Fourier transform of gx denoted by gs. Then Fourier inverse transform of fs into gs is nothing minus infinite to infinite fu g x minus u du. This is very important formula. So whenever fs and gs we know, so what is our work? We have to calculate f inverse of fs into gs. So whenever they ask inverse Fourier transform of any function, so first choose fs and gs value. Once you know fs and gs, calculate its inverse Fourier transform. And inverse of fs is fx, inverse of gs is gx. So once you know small fx and small gx, just put value here and integrate, and you will get the result easily. Now I am going to explain Parseval identity, because most of question we will have to solve by Parseval identity. So what is Parseval identity? Parseval identity for Fourier transform first. Suppose Fourier transform of fx is given fs, and Fourier transform of gx given gs. Then Parseval identity is 1 upon 2 pi minus infinite to infinite fs into gs conjugate ds is equal to minus infinite to infinite fx into gx conjugate dx. This is first part, and second part is 1 upon 2 pi minus infinite to infinite fs whole square ds is minus infinite to infinite fx whole square dx. So my friends, if Fourier transform of fx we know, that is fs, and gx Fourier transform is gs, then Parseval identity is in two parts. Are this one, first part is 1 upon 2 pi minus infinite to infinite fs into gs conjugate because we are working in complex field. So complex number is there, then we can write its conjugate, just replace iota by minus iota, is equal to minus infinite to infinite fx into gx bar dx. And second Parseval identity 1 upon 2 pi minus infinite to infinite fs square. So my friends, here it is important to note that this identity we are going to use where power 4 type question is there. If find the evaluate the integral of some power 4 type is equal to minus infinite to infinite fx square dx. We will do the question based on that so that you understand easily. Now, the most important part of Fourier transform, Fourier cosine Parseval identity for Fourier cosine and sine transform. So, second, for Fourier cosine transform, the Parseval identity is 1 or 2 upon pi first, 0 to infinite fcs gcs ds is equal to 0 to infinite fx into gx dx. And second, 2 upon pi 0 to infinite FCS whole square ds is equal to 0 to infinite fx whole square dx. Third, for Fourier sine transform, the first identity is 2 upon pi 0 to infinite, same type, f ss g ss ds is 0 to infinite fx gx dx. And second, 2 upon pi 0 to infinite fcs whole square fss whole square ds is 0 to infinite fx whole square dx. So my friends, this all first, second and third are the Parseval identity for Fourier transform. This is just for Fourier transform, this is for Fourier cosine, and this is Fourier sine transform. Based on the question what is given, we have to check first which identity we are going to use, Fourier transform general or cosine or sine transform. Here it is very important, you have to know Fourier inverse transform of some function. And based on question I will explain something, but if you learn some Fourier transform of some basic function, then it's very easy for you. So I'm going to solve one question which is very standard result, and same type problem you already solved in Laplace transform. So the question is, evaluate 0 to infinite 1 upon a square plus t square b square plus t square dt, and so the dt, and calculate its value. So my friends, if you know, if fx is e to the power minus ax, then its Fourier cosine transform is a upon s square plus a square. This you can do it easily. Similarly, if gx is e to the power minus bx, then its Fourier cosine transform of gx means we can write gcs is b upon s square plus b square. So now we use which Fourier transform? Parseval identity for Fourier cosine transform. So Parseval identity for Fourier cosine transform is two upon pi 0 to infinite FCS GCS ds is 0 to infinite fx gx dx. So just put the values. What we get? What is FCS? FCS is nothing a upon s square plus a square. What is GCS? GCS is b upon s square plus b square is equal to 0 to infinite. What is fx? Fx is e to the power ax. What is gx? E to the power minus bx dx. Just ab is constant this side. So 2ab upon pi integral 0 to infinite ds upon s square plus a square s square plus b square is equal to, this is nothing, a to the power minus common a plus b of x dx. You know, we have to calculate this integral value ds upon a square plus s square b square plus s square. What is the value? Pi, we take that side. So pi upon 2ab. What is the integral value? Integral value of this, e to the power minus a plus b of x upon a plus b minus limit is 0 to infinite. When we put infinite, e to the power minus infinite becomes 0, and when we put 0 it becomes 1, and because minus is there, the value is 1 upon a plus b. So what is the answer? Pi upon 2ab a plus b of the integral ds upon a square plus s square b square plus s square. So hope you understand this problem. This is a very simple problem which I solved here using Fourier cosine transform and Parseval identity. So now I am going to solve some more question based on that. Now one more question we are going to solve. Suppose they ask you to evaluate 0 to infinite t square upon t square plus 1 whole square dt value, and so this is equal to pi by 4. Suppose so that this integral they ask, then how you can do? Here again, my friends, you have to know, if we take fx value x upon x square plus 1, then its Fourier sine transform is nothing pi by 2 e to the power minus s. My friends, there is no method to know about, I can't tell any trick so that you can know easily. But only one thing I can say, see here t upon t square plus t square and t square plus 1 whole square is there. So it means what we have to choose, x upon x square plus 1, then we can use a Parseval identity of second type. Means now Parseval identity is using Parseval, because we know Fourier sine transform of this function is this. Then we are going to use using Parseval identity for Fourier sine transform. What is that? Second type. Because here is square required. So best is we use, it's your choice, you can use any type. But if you use 2 upon pi 0 to infinite fs whole square ds is equal to 0 to infinite fx whole square dx. Just put the value 2 upon pi. What is fs? Pi square by 4 e to the power minus 2s ds. What is the right hand side? Right hand side is 0 to infinite x square upon x square plus 1 whole square dx. So what is left hand side value? 2 upon pi, take pi square by 4 outside. What is integral value? Integral of e to the power minus 2s is e to the power minus 2s upon minus 2. And what is the limit? Limit is 0 to infinite. What is right hand side? 0 to infinite x square upon x square plus 1 whole square dx. Now you simplify this, pi cancel, 2 cancel. Now when we put infinity, value is 0. When we put 0, value is minus 1 by 2, because minus minus it is pi by 2 into 1 by 2 is value of integral 0 to infinite x square dx. So 0 to infinite x square upon x square plus 1 whole square dx is equal to pi by 4. So hope you all understand this type question. One again, my request, my friends, the Fourier transform, whatever you calculated, make a chart, because Parseval identity we can do easily if we know Fourier transform of fx is what, because it's important. And sometimes if you go for your examination, then sometimes they will give the Fourier transform of Fourier sine transform of this function is this. Then use Parseval identity and do it. If not, then it means you have to know. And hope you can do these type questions. And remaining question, if you have any doubt, you can ask me. Just you write in a comment box and I will do that problem, whatever problem you have. Not only that, any problem related to mathematics which you want to know, no matter it is which level. And believe me, I will try to explain you in easy way. Thank you.